Okay, just one thing I noticed. Something you didn't tell, it's actually, I'm French, and I like the French soccer player team. That's fine, that's a World Cup. And my talk, no, it's fine, it's fine. And actually, my talk will finish just a few minutes before the French soccer player team is playing this afternoon. You know, I suspect you just to make sure that I finish on time. But I'm French, so I will be late. I'm sorry. Another thing I wanted to tell you, and that's really important for me to understand that, if I have a long hair and a beard right now, it's because I worked on ADB, and ADB is boring, really. And that's really something that you will feel in this presentation, I think. It won't be my fault, it will be the fault of ADB, okay? So let's try that. I have two short questions for you. First, who is an Android developer in the room? Raise your hand. Okay. No, that's fine. Okay, just keep your hand raised if you are an Android developer who thinks in the room that he is using ADB a lot every day, something like that. Oh, that's crazy. There are more people raising their hand when I ask for if you are using ADB than people if you are Android developers. That's okay. Actually, for all the people that didn't raise their hand, you're wrong. For all the people that raise your hand, you are really right. You are using ADB all the time, and we will see that during the presentation. So, about me, I'm Eyal, but you don't really care. I'm working at Qonto. We are recruiting, but in France, so basically you should not care too much if you are not living there. Anyway, that's a funny company. And if you want the slides, they are already available on the link that you have here, so bit.ly/adb-chill. I'll let you keep the picture, take the picture, and then we go. Okay, so what we will talk about today. First, just a big picture of how ADB is working. We will also dive a little bit on some ADB comments that you maybe already know. And then we will go a little bit deeper about what the internals of ADB. And we'll finish by two things. First, if you want to work on the ADB project, how to do it. And of course, because you are using ADB a lot, we'll see how the Android dev tools are using ADB. Okay, first information. ADB stands for Android Debug Bridge. And actually, it's a command line tool that allows you to communicate with a device. These Android devices can be physical, so real devices, hardware, etc., or emulators. ADB is part of the SDK. You can find it on the platform-tool directory. And there used to be two versions distributed, because there used to have a preview channel that I didn't see for 1 year or something, but so maybe it could come back. Anyway, how ADB is working. You have three parts on ADB. You have the client, you have the server, and you have the daemon. The ADB client is the command line tool that you are using. So actually, when you are typing on your terminal ADB something, you are executing, you are instantiating the ADB client. You are running it. On the other side, you have the ADB daemon. This daemon is running on a device. It's started by the Android system as a background process. And the role of this daemon is to execute your order on the device, whatever order you ask. In the middle of these both elements, you have the ADB server. And actually, the ADB server is the real bridge of the Android debug bridge. It will link the client and the daemon. So let's take a practical case. When you are running a command, you are executing the ADB client. And the first thing that the ADB client is doing is that it will ask himself, is there an ADB server running on this computer? If it's not the case, of course, it will start the ADB server. And what the server will do, it will open a TCP server on the port 5037. There is another thing that I didn't tell you, is that in English I'm very bad, but with numbers I'm worse, so I'm sorry about that. So the port is 5037. and listening to ADB clients wanted to communicate with this. And the second thing that the ADB server will do when you start it up, it will scan for Android devices and Android emulators. How it does it? For example, for the emulator, it will look for the local host network interface and look for this port range, so from 5555 to 5681. And it will look for odd numbers to find an ADB daemon behind. And it will just crawl this range of ports. Just one thing, why it's only the odd numbers and not the other one. It's because when you are starting an Android emulator, there are two TCP servers running on the device. One is for the ADB connection, and the other one is a serial port one that is not that used in our use cases. So it will crawl and it will try to find a device. So for example, if I have a device behind this port, of course, the ADB server will, from itself, open a connection to this ADB daemon, and then when you will type ADB devices, you will see this device on the list. Okay, that's the same for the USB interface. Actually, it's not exactly behaving the same, but that's exactly the same logic. Looking for devices, and when it's done, it will connect to this device. And it will work for different kind of devices. You will have the Android Studio emulators, you can have network devices, and you can have hardware devices. Network devices are devices that are running on your local network, and we'll see that just in a few minutes. So we have our big pictures. The ADB client and the ADB server are running on the computer. The ADB client discusses with the ADB server to just relay some comments. And of course, the ADB daemon on the devices are connected to the server and executing your comments. Okay? We're all good for that? Yes? Okay, let's go. Let's see some comments. As I told you, you can actually discuss wirelessly with an Android device. You can develop on a remote device that is not connected through USB. It's pretty easy to do. You have actually two commands to type. The first one is to, of course, first you must connect your device through USB, and then you type ADB TCP IP, and then the port number, the default port number, it's 5555 for the ADB daemon. And then you can just unplug your device, connect this device to the wireless of your, I don't know, your office or your home, and type ADB command and the IP of your device. And it will open this connection. And you will be able to see your device when you are typing ADB devices. Okay, it's cool. If you want to undo this, if you want to disable the wireless debugging, just type ADB USB, and you are good. It's coming back to the previous state. Okay, it's funny, it's interesting, but let's try to digging into a little bit, understand a little bit what's behind this command. So when you are typing the ADB TCP command, what's happening exactly? The ADB server will ask to the daemon to enable the network connection. Okay? Actually, it will send this payload, and we will see about the payload later. Then, what the daemon will do, it will set a system property on the Android device. Actually, the command that is run is really that, set prop, and with this long property name and the port 5555. Okay, and then what it's doing, it's pretty strange. It will just kill itself. No ADB daemon anymore. But there is something that is interesting, is that because the ADB OS is running the ADB daemon as a system daemon, it will reverse it automatically. Actually, the OS will launch again the ADB daemon. So it will restart, and when it restarts, it will read the property that has been previously set. The name is service.adb.tcp.port. And when it's starting, it is able to open this network connection. So that's the way it behaves. But there is something interesting behind. If you have a routed device, actually, you can do it yourself. You don't need this ADB TCP. So running the 3 commands, you do exactly the same what ADB is doing. Set prop, then stop ADBD, then start ADBD. Okay, cool. But the only thing I wanted to point it out is that on some environments, when you are routed devices, and you want something a little bit more tricky, because when you are doing ADB TCP IP, if you reboot your phone, you will lose the network configuration. Actually, if you reboot your phone, you are obliged to do ADB TCP IP again. But if you type this command, ADB set prop, and instead of service, you type persist.adb, etc., these property will remain. And you will be able to reboot your phone and keep this wireless configuration over all the reboot. So that was the thing I wanted to show you. If you're digging a little bit, ADB, there are some magic tricks that you can do. OK. Another thing that you maybe heard about, ADB devices, right? But there is this option, which is -L. If you add it, you have more information about your devices. So for example, you see on the first line, we have a Genymotion device. On the second line, you can see that it's an Asus and then a Nexus 9. That's pretty interesting when you are automating your test or automating your infrastructure with Android devices, to be able to recognize your devices on an easier way than just having a serial number that doesn't mean anything. Another thing I wanted to show you, I told you that there are some network devices, there are some emulators, and there are some physical devices. You can actually filter these devices for every Android command you do. You know, sometimes you are doing ADB-S and you put a serial. And you have the same kind of filter for network devices and for real devices. Not really interesting for you, but I will show you what is the impact on the internals a little bit later. Another thing that I wanted to show you, that's a nice trick if you have, again, some kind of infrastructure and you want to communicate with remote devices in your company. These both options, -H and -P. These both options allow you to, from your client, to target a remote ADB server running somewhere. Let's take an example. ADB.H, and you have this IP, and .P with with a port, which is the default one, by the way. You remember this number, 5037. So what's happening? You have your ADB client that will communicate with a remote ADB server, for example, running on a device farm server in your company. And this farm server is, of course, connected to several devices. And it makes this remote farm available to your local computer or to your CI or everything you want. Just you need a static IP for that. OK, another thing I wanted to show you. Who knows ADB forward command? Raise your hand if you don't know it. Oh. OK, I won't explain you this command. But I will explain you ADB reverse, which is the reverse of the forward. So if you understand the reverse, you should understand the forward too, right? Yeah? Well, some people are very worried about what I'm saying. So let's see what's the magic behind that. Just to let you know, ADB forward is behind the ADB debugging. When you are debugging your app, actually you have an ADB forward command, some kind of running behind. So just you can start to understand what what you can expect from this kind of connection. So ADB reverse and ADB forward, both commands are aimed to bind 2 ports on your computer and on your device. So the idea is that I have my computer that is running, for example, my local backend server locally when I want to develop. And it's running on this port, on local. And I have my application that is supposed to target, to call localhost on a specific port, and I want that these requests arrive exactly to this port. And reverse is doing this. If I do ADB reverse TCP 2323, sorry, and TCP 8181, it will bind the both. So if on my application I start a HTTP request on localhost and this port, it will arrive on my backend server. That's exactly, it's pretty interesting when you are in development, when you have a staging, for example. I found on some companies, for example, they have a VPN. And it's cool because staging is running somewhere in the cloud behind a VPN, so it's protected. But for Android devices or every kind of devices that doesn't have a VPN configured all the time, it's really tricky to handle. But as a developer, it's pretty easy to handle this kind of thing with the ADB reverse. What I do is on my computer, I open my VPN. It's connected, of course, to my secured backend server somewhere in the cloud. And I use a proxy locally. And then I bind this proxy to the proxy of my device. It's pretty easy to do. Oh. When I say pretty easy and I show this slide, of course, people are laughing. But it's pretty easy. What I do in these three command lines that allow you to do exactly this configuration. The first, I'm running a Docker with a squid, which is a reverse proxy, very simple reverse proxy. So this will run my proxy, sorry. Then I do ADB shell setting and put my HTTP proxy. In this case, it's 3333. And then I bind the both squid configuration here to my reverse proxy to the proxy setting on my device. And when I've done that, I can very simply from my device send requests to my secured backend. Okay, so that was the hard thing on the comments. But it's pretty handy for many people that have this kind of configuration and are always obliged to deal with OpenVPN clients and things like that. By the way, if you are looking for more information about that, on the speaker notes of the slide, there is the squid configuration file that I use, which is really simple. You don't need something tricky on that. Okay, last command I wanted to show you. It's ADB. Actually, what I will show you, you cannot see it anymore. It has been removed less than 1 year ago, but it has remained in ADB for something like 8 years. So it's still worth showing it to you. So ADB command, what's happening when you are typing this command? If somebody have an ID. Yeah, it shows the help, exactly. But what it used to show in the help is this thing. It's the documentation about the -p command that I didn't tell about, that you don't really care because it's mostly focused for Android OS developers. But there is something really strange here. A name that I never found anywhere before. Sooner. So the sentence is simple product name, like Sooner, and etc. So when I read that, I say, well, what is a Sooner? I remember the first devices and all the Nexus code name, no Sooner in it. So who knows what's the Sooner? Nobody. Oh, I like it. Here's the Sooner. The Sooner is the very first Android phone that have been designed that have never been released. Actually, the story behind that, it's a really long story. There are a lot of debates behind that. But actually, the Android team was making the Android OS more stable at the before the first release. And it took more time than they planned. And actually, they had this phone that was targeted to be the first Android phone released. and sell. But it took too much time, and the hardware of this device get outdated, so they had to drop this device, and actually they released the G1, the HTC G1 that maybe some of you know. So this is the Sooner. And there is another thing I wanted to show you about the Sooner. It's the reaction of a guy that you maybe heard about, Andy Rubin, who created the Android company. That's his reaction when he's seen the iOS presentation by Steve Jobs when they announced the first iPhone, sorry. So he said, people said that he said, holy crap, I guess we are not going to ship that phone. And actually, he was talking about the Sooner, just to let you know. So you see some gems that we can find on ADB. It's pretty surprising, right? But it's still boring. OK, let's do more boring things, the ADB internals. Oh, this part will be long, but at the end, you will see there is another fun thing to learn. OK, so just stay with me. ADB internals. So we have our big pictures, the ADB client, the ADB server, the ADB daemon. And actually, all these parts are talking to each other, and they have a specific protocol to discuss with each other, and each one have evolved. So I've named them. So the first one is CS for client server, and the other one is SD for server daemon. Okay? Let's start with the client server. So when I'm typing an ADB shell ls command, just the command to list all the root file system. Yeah, you understand that, right? You get it. So just to list the file at the root of the file system. So when you are running this command, what's happening? The ADB client will send a message. Actually, it will ask a question to the ADB server. What's your protocol version? And it does that by sending this payload, host::version. The ADB server will answer, OK, which is, OK, I get your question. And here is the answer, 36. So the version is 36. The next thing it will tell is, I want to talk to any kind of devices. Because when you are typing ADB shell ls, you are not specifying any kind of device or a specific device. So it tells that to the server. And then the server says, OK, I got it. And last thing, finally, the ADB client will send a payload to execute the shell service with the parameter ls, which is the command that we want to run, on the device. And the server will execute this ls and send the output. So you see, when you are typing an ADB client command, a command line on ADB, you have this kind of conversation. And it's always the same pattern. You have the startup with the version check. You have the device selection. And then you have the service execution. And that actually helps us to understand something. Have you ever encountered this kind of errors? ADB server version 32 doesn't match this client, which is 36. Or ADB server is out of date, killing, etc. That's something that, thanks. Thanks for your participation. That's something that we met a lot, actually. And actually, the problem is that the version of your client is different from the version of your server. So every time you have this kind of problem, you can be sure that it's because the server that is running is not the same binary than your ADB client, the one that you are using on your command line. So it won't solve your problem, but now you know why you have it. About the device selection, actually, I told you when you are not specifying any device, of course, it will tell us every device, but you can also select, you know that. And actually, there is a specific payload for each of these things. So what's if we just put that in a nutshell, we have the ADB client that will request a service execution. Then we will have the ADB server that will execute the host services, for example, listing the list of devices are host services. And the daemon will run what is called the local services. Just a few examples. Don't read this, okay? Really, it's for the people that want to come back to the slide later. But a few things that I wanted to show you very quickly. So here are all the host services. You can see, for example, when you are typing devices-l, that's the specific service. And others. One that is really interesting, I told you already about ADB Forward. Actually, you have this specific service, which is called JDWP, which is the one that is used by the Android Studio to debug your application on your device. Nothing really interesting, but just to let you know that there are very specific, every feature that you use on ADB have a service that is defined. Okay, server to daemon. Let's do the other one. So you have a message that is going through from the server to the device and on the other way. So what's this message looks like? It looks like this. And if we start to fill in, there is a header, which is called an A message. And then you have the data that is what the payload contains. When you are transferring binary, you have a big part of the data, right? So the A message is pretty simple. Actually, it's a C structure. And what we can find in this structure is, first, we have an unsigned, which is the verb of the action. So you will see in this protocol, you have actions. You have arguments for the action. You see the name are pretty generic, arg0, arg1. Actually, these parameters, the meaning of these parameters depends on the command. And the other thing that I wanted to show you is that you also have the length of the data. So you have the length of the blue part here on the header of the message. OK, cool. Now, if we are doing an ADB connect with an IP import command, what's happening? Actually, you have the ADB server that will send this payload. OK, just don't be afraid. We will see that together. So this payload, you have the first is the command, then you have the arg1 and the arg2, okay? And this command is cnxn, which means connection. Then you have the protocol version, okay? You don't really care. But the thing that is interesting is the maximum payload size of the server. Because, of course, the blue part, if I come back, the blue part, I have a maximum payload size, okay? And the server, when it connects to the device, tells, okay, this is my maximum payload size. Then the daemon will answer. It will answer almost with the same content, including, of course, his own maximum payload size. And what you will find also, it's interesting, at this moment, you have this string, which is called the device identity string. Actually, that's exactly the string that you can find on ADB devices-l. This string is stored in the ADB server, and it's displayed simply when you are doing a -l. So it's defined by the device itself. OK, another command, just to go a little bit deeper on this protocol, ADB shell ls. So let's make it shorter. ADB server will open the new conversation with the open verb and send, of course, the service to execute on the daemon. Then the ADB daemon will answer OK, and it will start answering with a write payload, a write message. OK, then the ADB server will send OK to answer, OK, I got your write data. You can continue to send it if you have more. And of course, it has more, so you have 2 write data that have been sent by the ADB daemon, and then it closes the connection. So the ADB server will answer OK for the write, and then close for the close. OK. But, and that's the interesting thing I wanted to show you. I don't know if you remember, that was between 2015 and 2016. the Android team announced that ADB was about to be really faster. Does somebody remember these announcements? Raise your hand if you remember. Okay, just a few of you. For the people that didn't know, the very first time somebody from Google told about that, it was at the Android Dev Summit in November 2015. And it was someone very important on the Android team. The announcement had been done by Stephanie, which is one of the main manager on the Android team right now. And look at this chart. She announced something that is crazy. It's really, really, really faster. I mean, I cannot count right here. But I mean, when you see this kind of chart, you say, wow, they are dealing with the new physics. I mean, they are, putting they are breaking all the rules, right? Yeah, they are breaking all the rules, and we will see together what they've done to increase the speed that much. Okay, so just to let you know, right now on ADB, a few years later, the maximum payload size is 256 kilobytes. But before, it was only 4 kilobytes. So you see the difference, right? And if we just want to put a picture on this a little bit more, if you have this kind of conversation between the ADB server and the ADB daemon, they are exchanging 2 writes, okay? Just 2 writes. But if you put that with 4 kilobytes messages, it looks like this. So you get the difference, right? And you get the magic, which is actually not that magic, just engineering. That's boring, I told you. Okay, so we finished with the internals. Now we have a little bit more information about how they are discussing. Of course, you are all thrilled to contribute to ADB, right? Yes, me too. Let's develop an ADB, just focus on what's this project, actually. So just very easy to do. You configure your environment, you fetch the source code, you make it, and then you build your own ADB. And this is not a joke. I see people laughing. It's not a joke. You can do it, really. It's really easy. For example, I'm on the Mac. I have a setup to do my own ADB right now. Just a few comments, and you're all set. So repo init, and just take the very simple. So when you are doing this, actually, you are downloading the Android open source project, which is the source code of Android. So init, sync, and then you configure your environment, and you are building ADB. And you can build for your own platform your own ADB with the source code that you can modify. So actually, what you are doing when you are building ADB, you will build 2 binaries. The first one is ADB, and the other one is ADBD. ADB is the client, the real client that you are using on the platform tools. There is the path where you can find it after the build. And the ADBD is the daemon that is running on the device. And you are using it also every day, but you don't notice. And there is something in the middle, which is called libadb, which is a static library, which is shared by both ADB and the ADBD. So it means that a lot of source code is shared between the ADB and the ADB daemon. They are running on different platforms, but they are sharing a lot of source code. A little bit of history about the ADB source code project and code base. It used to be developed in C because, of course, system engineers develop in C by default. And they move on to C++ a few years ago. So what they've done, basically, is that they change the extension of the files, and they change the compiler. So you still have a C-styled code base running this very complex code. And to be honest, I dealt a little bit with the Android, the ADB source code, and for me, it's not C++. It's something that I found a few names. Just let me know the one you prefer. So my first one is C++, just only C++, or C about ++, or C++ minus, which is the one you prefer. That's something like this. Yeah, and the problem with the ADB source code is that it's ubiquitous. It means that it runs on the ADB client, the ADB server, the ADB daemon. It's huge, and it's running also on 3 platforms, including, of course, Android. Not including Android, of course. Actually, Linux, Android, etc. But you get the point. It's really ubiquitous. So you have source code that is running everywhere. And it's hard. And another thing is that ADB server is a multiplexer. I don't know if you already developed a multiplexer. It's something that takes a lot of input and put all these inputs on many other clients, and doing the tunnel on the both sides. It's extremely complex in terms of design. So if you add all these constraints of language, of platform support, and of natural functional complexity, you have some kind of a nightmare. But it's pretty interesting. It's boring, but it's interesting. For example, what you can find in the ADB source code, this kind of thing. So if ADB host, it means that if it's running on the computer, you can find it 62 times on the source code. Or an exception for Windows, you have more than 50 times like this. So you are dealing with this kind of a hack. The good thing is that you can debug ADB. Already, if you have problems with connection, I don't know if you are doing tricky things with ADB, you can do it by yourself. So you kill the ADB server. Then you export an environment variable, ADB underscore trace, and you put the value to ADB or to all, depending on your need. And then you start the server again. And then you will have logs, more logs. For example, if you type ADB devices, you will have the detail of the conversation. Do you remember host column devices? This is the payload that is sent to the server. And you also have the ADB server logs, so it's stored on the specific file. On Linux is on a temporary directory, on Mac also. I didn't put it on Windows because I didn't find it, so if you want to find it and send it to me, just let me know. And basically, you can very easily debug your Android problems right now, already. OK, so now let's finish with our, I'm already late, right? 3 minutes. Oh, OK. Yeah, I will be just a little bit late. So the ADB and the Android DevTools. First, Android Studio. You want to know about Android Studio? You can download it. That's exactly the same thing that you can do with ADB. That's hosted on the exact same place on the Android open source project. So if you want to download it, 3 command lines and you get it. OK, first information for you. Android Studio does not use ADB. What a surprise. Almost. Actually, it uses DDMlib. But what is DDMlib, right? DDMlib is a Java library that behaves like the ADB client. And it's also part of the AOSP, so when you are downloading Android, you will find it. And you can have the source code very easily. But another information for you, DDMlib doesn't use ADB. Almost, of course. Actually, DDMlib uses ADB only to start the ADB server, and only this. And then it will behave exactly like the ADB client, right? You get it, right? So a question, why should I use DDMlib instead of the ADB binary? I mean, it's Java specific, etc. Why? Actually, there are many reasons, but one is very important, the backward compatibility. So you remember, with the ADB client, I told you before that if you are not using the exact same version between your server and your client, you will have an error, right? Actually, for DDMlib, it supports all the version until since the 20th version of ADB, and this version has been released in October 2008, so it should be okay, really. Yeah, so a few other points about DDMlib. It's maintained by Google. It's fully open source. You have many thousands of daily users because you are all users of DDMlib. And the only drawback, which sounds pretty logical, that you still need the ADB binary. And for me, you should consider using it if you want to communicate from a GVM side application with an ADB, because it's a very good tool. It's really bulletproof, etc., and very easy. And something that is really awesome about that, it's hosted on the Google repository, so you can download it today, which is like a keynote announcement, but not from me. Yeah, it's available already on the Maven repository from Google. I will be short for the last, okay? Okay, the Android Gradle plugin. You know that Google is maintaining an the Android plugin. Of course, this plugin is also open source. You can download it. The other, you have all the command line for that. The Android plugin uses DDMlib, of course, like the Android Studio. But the question, how does this plugin is using DDMlib? Actually, it uses DDMlib every time it needs to interact with a device, of course. When you install an APK, when you launch your instrumentation test, or get device information, which is done, for example, for instant run, to check the version of the device, it will use DDMlib. Just a few classes if you want to hack around, because there are not public classes. But if you want to hack with this plugin, you can do it with it's 2 entry points, but I won't go deeper. Something which is really interesting, and I will take just a few seconds to tell about that. If you copy-paste, actually, if you access the DDM preferences and set the log level to verbose, if you launch a Gradle task that is using ADB, you will have outputs. And it's really interesting when you have problems running your instrumentation test. For example, when you do that, you have all the details of the commands that are run on the device. And you also have in clear, all the results from your device to the Gradle plugin before it's parsed to XML and HTML. That's really interesting when you want to debug. Yeah, that's my last slide. Actually, it's not, but anyway. No, that's fine. You have Android ADB options on the Android DSL. Just dig in if you need. It's sometimes very interesting. And I want to thank you for your patience.